All right, so we've got sine squared is equal to 0.77. We need to find cos squared. We know through the Pythagorean identity that sine squared is just 1 minus cos squared, and that's the same, so we can line it up like that. So now we know 1 minus cos squared is equal to 0.77. Now we're going to bring that negative, or the 1, to the other side. So I'll have negative cos squared theta is equal to 0.77 minus 1. We'll have negative cos squared theta is equal to negative 0.33. Now, we have two negatives. What we need to do is we divide off a negative 1 from both sides, which will get us cos squared theta is equal to 0.33. Nice, simple, and easy for the first part. Second part, a bit trickier. We have to notice that there is a domain altered right here. My trick for this is the outside terms do not alter the domain. All this does is increase or decrease the final value, and this is just a scale factor. This middle part, whether it's a phase shift or a scale, horizontal scale, a period change, these are the two that affect the domain. So we have to recognize that this is a multiplication by 2, so we'll have to multiply our domain by 2, and we'll have to subtract 90, because that's what's happening. So these are the two individual operations that we have to perform on each of the terms in our domain. So negative 400 times 2 is going to be negative 800. Subtract 90 is negative 890. That's going to be less than or equal to 2 theta minus 90. Remember to keep those brackets to make it true. And that is less than or equal to 200 times 2 is 400 minus 90 is 310 degrees. Remember to have your degree symbols. Okay, now that we have that, we can find the related acute angle. To do that, we have to simplify the expression a bit more. So we have 4 tan 2 theta minus 90 degrees. Bring that 3 over to the other side, which will become a negative. So we're going to have negative 4. And to isolate just the tan and its inside bit, I don't really know what else to call it. I just call it the inside bit. We're going to divide both sides by 4 to get rid of that 4 coefficient on the front of it all. So we're going to have tan 2 theta minus 90 degrees is equal to negative 4 over 4, or that's just going to become negative 1. Now that we know it's negative 1, we can solve for the related acute angle. So we'll have tan of, let's call it alpha, is equal to negative 1. We know that negative 1 is one of our ratios that we should know. So alpha is going to be equal to 45 degrees. Now that we know this, we can go onto our Cartesian plane and find out where we're going to go. We know that we have a negative sign, so we're going to be working in quadrants 2 and 4. Let's put a 45-degree line in here. And we're going to have the related acute angle here. Oh, come on, if my pencil would work with me. Here and here. So these are the two angles we're dealing with. So to find the first angle, let's go theta 1. Actually, it should be 2 theta 1. 2 theta minus 90, but I'm not going to write that all out. That's too much work. I don't feel like doing that. Is going to be equal to 180 minus 45, which is equal to 135. Now we're going to go through all the steps. Obviously, we run into a domain restriction pretty fast. If we want to do the next one, we'll do theta 2. We're going to have 360 minus 45, which gets us 315, which is outside of our domain restriction. So this does not work. So now we have to go the other way. Let's find this angle, but going in this direction. So we will have negative 45. We just know it's negative 45, so theta 2 is equal to negative 45. Theta 3 is going to be all the way around here, so we're going to have 180 plus 45 Remember, this is all negative, but I'm counting it as positive just to make it easier for myself. You could do negative 180 subtract 45, and that would get you the same answer, but I know through addition, I just need to add a negative sign after. It just makes it easier to work with. So theta 3 is going to be 225, negative 225. Don't forget to add that negative sign. I almost made that mistake myself. We're going to have theta 4 is equal to negative 405. I'm just going to speed this up. You all can figure out the angles yourself. Negative 585, I believe. And then 6 will be negative 765. Now that we have all of our 2 theta angles, we can create our therefore statement. Actually, therefore, we need therefore up there. Okay, therefore, 2 theta minus 90 is equal to 135, negative 45, negative 225, negative 405, negative 585, and negative 765. Now, to get it back to theta, we need to do these operations reverse. So we need to divide this number by 2 and then add 90. That's how you do it, because we want theta, and to get theta, we need to do the opposite. So let's break it down for 1 so that we can see it over. So we have 2 theta minus 90 is equal to, let's say 135. So we need to do 135 divided by 2. So we will have theta minus 90 is equal to, I'm going to do this, can't really do it. I should probably be able to do it in my head, which is quite sad, but it's okay. 67.5. Of course, my lead keeps falling out. This is 67.5. Now that we know that, we have to subtract 90. And we're going to get theta is equal to negative 22.5. Now, I'm just going to speed run all of this. So therefore, theta is, these are the answers you should get, in ascending order. Negative 292.5 degrees, negative 202, oh my goodness, 202.5 degrees, negative 112.5 degrees, negative 222.5 degrees, 67.5 degrees. Actually, I did it backwards. I subtracted, I should have added. That is my mistake. That is going to be that's going to be 157.5. See? Because you take the negative 90 over to the other side, and that's actually addition. I made that mistake. And you're going to get 157.5 degrees. So theta is going to equal negative 292, negative 202.5, negative 112.5, negative 22.5, 57.5, and 157.5. There you go.